the Algebra of Probability. On your textbooks, it starts on page 547. Your homework's on page 550 and 551, and it's going to be all problems 1 through 26. Okay? We talked a little bit about mutually exclusive events last time, and we talked a little bit about when you want one event and another event to happen versus one event or another event. So we're just going to touch on that a little bit more and review all the probability functions or formulas that we have so far. Okay, so mutually exclusive events, that means that if one happens, the other cannot happen. So if something is red, it cannot be blue. If something is square, it cannot be round. Things like that, right? When you write them, you write mutually exclusive events. And the way you define them is, I think that's a symbol, right? Sorry, the union, of course. I always get confused with the U and the upside down U. The U means union, which basically means both things happening. So the probability of both of these events happening is 0. That's how you know they're mutually exclusive, right? So that's a definition for it, but it just makes sense. Mutually exclusive cannot both happen. If one happens, the other is impossible. It will not happen, okay? And so we have probability formulas that we can use to calculate this stuff. It's kind of like the counting formulas. I think they're a little bit more intuitive. Even if you don't necessarily remember the formula, if you kind of think, okay, probability is just odds, and if you just kind of think about it logically, you'll come up with the formula even without having it memorized, okay? So, there's a couple of different scenarios, and the first one I'm going to write is that when they say the union of two events, again, remember, it just means both events happening, okay? So, if you have two events, which are E1 and E2, if you have 3 events, the third one's going to be called E3. It's super creative. And you can call your total event is going to be both of these events happening. Right? It's the union of both of them. So what we're going to figure out, even though it's 2 events, what you want is the probability of both of the events happening. So what you're going to figure out is the probability of the overall event. The overall event is both of these things together. And remember, U is the first letter in union, and union just means and, okay? So let me tell you the couple of ways that this can happen. And P is just probability, right? Oops. Okay, and if you look on page 547 in your book, there's a nice little graphic illustrating it. And again, this is all fancy wording of probability, but just think about it. Okay, the probability of one event happening or another event happening, basically, right? So this is the union of 2 events. So probability of event 1 and event 2 happening, right? Is just the probability of event 1 plus the probability of event 2. That is if they cannot happen together. So that just means if they are mutually exclusive. That'll make sense in a minute, right? You have the probability of one event over here, the other event is not going to happen at the same time, so you add those 2 probabilities. Well, if they're not mutually exclusive, which means they could both happen at the same time, then you have to do the probability of your first event plus the probability of your second event, but then you have to subtract the probability of both events happening. Why is that? Well, let's say we're looking, you have a bunch of different shapes, geometrical shapes, and they're all different colors and they're all different shapes, right? So if you're looking at the probability of something being green and being a triangle, or being a triangle, for example, right? Here's your probability of it being green, probability of it being a triangle, except in both of these, you're counting the probability of it being green and a triangle. So you have to subtract it once just to get rid of anything you're double counting. And that's why I like the little graph that they showed at the bottom of 547. Sometimes both statements are going to be true, and that's going to be double counted, but it's still just one event. So that's why you have to subtract that. And we're going to go through some problems, and I think you're not even going to really have to memorize any formulas. I think as you do them, stuff will just kind of make sense. But these are the formulas that are in the book, and you just have to remember, if two events are not mutually exclusive, you have to make sure you account for the fact that both of the events might have happened at the same time. And so you'll have to get rid of those. So you just subtract anything that's getting double counted. It's pretty straightforward. So let's look at example 1, and actually after example 1, it gives you another way to solve it without using any formulas, and you might like that better too. So, example 1, in a certain algebra class, 5 of the 8 girls have blue eyes. So, we have girls. I'm going to make a little table. Little Punnett square type thing, right? So, the rest of the people are clearly going to be boys. And we have blue eyes and not blue. We could add another table where we have total, but these numbers are small enough that I think we can just handle the math ourselves, right? So it says 5 of the 8 girls have blue eyes. So that goes right here. Well, they said 5 of the 8 have blue eyes. So if we have a total of 8 girls and 5 of them have blue eyes, how many don't have blue eyes, Alicia? 3. So we can just do that math. We don't have to do any fancy formulas or calculations. Now for the boys, what does it say? It says 6 of the 10 boys have blue eyes. So we know that 6 goes here. Lucas, if we have 10 boys and 6 have blue eyes, how many do not have blue eyes? 4. Right? So we can just do a simple table. Here we have all our possibilities. You can be a girl with blue eyes, a girl without blue eyes, a boy with blue eyes, a boy without blue eyes. All of these events are mutually exclusive, right? If you're a girl with blue eyes, you cannot be a girl with not blue eyes. If you are a girl with blue eyes, you cannot be a boy with blue eyes. So they're all mutually exclusive. And if you look a little bit further on your page, right underneath the example, you'll see where they use that drawing. So what are they asking? What is the probability of selecting a blue-eyed student or a girl, right? So what is the probability of selecting a blue-eyed student? And I'm just going to probability of blue for that. And then I'm going to do probability of girl for this. So first of all, how many students do we have total? Well, we can do this math, right? 10 plus 8, so we have 18 total. So we know that our denominator is going to be 18 for both of them, right? Because they want out of the total class. First question is, what is the probability of selecting a blue-eyed student? Again, these numbers are fairly small, so we can just do this logically. Blue, right here. How many total blue-eyed students are there? 11. Now we could add 5 out of 18 plus 6 out of 18 to come up with the total blue eyes, right? Then we'd be using a formula, but again, we don't need it. This kind of just makes sense. Now the other question is, or selecting a girl. How many girls are there? 5 plus 3 is 8. We're just going to leave everything over 18 right now because we're going to be adding stuff. Yes, this simplifies, but let's not worry about it. So what's the probability of one or the other? Well, let's see. It's 11 over 18 plus 8 over 18. Oh, what do I get? 19 over 18. Not possible, right? Your probability cannot be greater than 1. So even if I didn't remember any of the formulas, even if I'd forgotten everything, I'd say, well, I'm wrong because I can't have 19. And then I remember, wait a minute, some of the girls have blue eyes and are girls. So I'm counting those 2 times, right? Well, we have our little table, so we know that that is 5 of them, right? So you have to remember to subtract it. And that makes it a reasonable number. We're going to get 11 plus 8, which is 19. Subtract 5. We're going to get 14 over 18, but we know that that can be simplified. So it goes down to 7 over 9, which cannot be simplified because 7 is a prime number. Let's see if that's what the book got. 7 over 9. The other way you could do it is you could say, okay, which of these squares will give me a girl or blue eyes? This one, blue eyes. This will give me one that's a girl and blue eyes. and that'll give me a girl. So you could also just say 6 plus 5, which is 11, plus 3, which is 14. 14 out of 18, which is what we ended up with over there. Okay, so small enough numbers like this, you have